Welcome to a lesson with Dr. Powell. Let's talk about how we can use complex numbers to find the area of a triangle. Now, suppose we have coordinates for this triangle, 2, 1, and 3, 2, and 0, 0. Now, if one of the coordinates is not at the origin, we can always shift everything so one of them is. Now, after we have this setup, let's talk about how we can find the area of this triangle. So, what we need to do is multiply by something that puts this length right here on the positive x-axis. So to do that, we just take the complex conjugate of this guy and multiply it to that. So 3 plus 2i multiplied by 2 minus i, and that'll rotate so that this side right here is now like that, okay? Now what you realize that in the process we've also expanded, but that's actually good for us if we're finding area. We want to keep the expansions, which makes this process actually extremely nice and simple. We want to keep that expansion factor because what are we expanding by? We're expanding by the length of the base. So think of this as base. Think of what we want to do. We want to take base and we want to multiply by the height, okay, which is that perpendicular length there. We want to take this base and multiply it by that height. So really, we want to keep the expansion to get that. Then, of course, then we divide by 2 in the end. So we want to find the imaginary part of this, which will give us that length with the expansion, which is what we want. It'll give us height times base, actually. This is actually height times base. So we just need a 1/2 in there, and then we have the area of the triangle. So really, you just take 3 plus 2i multiplied by the conjugate 2 minus i, and then half it. You got it. That's all you do. So, of course, what we need the imaginary part of this multiplication. So it's 1/2 times the imaginary part. So let's get that in there. So 1/2 times the imaginary part, because the imaginary part gives us that. So 1/2 times the imaginary. All right. Imaginary, remember, is just O plus I, the OI of the FOIL. So the outside and the inside. So we have and we're just looking at the coefficients of I in order to get that. So we get -3 and we get +4. That's the O plus I. And then we divide by 2. And that'll give us the area. Notice that this is just a half. We just found the area of the triangle. It was 1/2. We did it fairly quickly. We just took 3 plus 2i times the conjugate, 2 minus I, did the OI. So we didn't even do the full multiplication. We just did half of the multiplication and halved it. Done. That was it. We just did it. Now, in order to ensure that we actually get a positive result for the imaginary part, I mean, if we don't, we can just change the sign. It's fine. We just need to make sure that our ground is, so ground to here is, this is counterclockwise. All right, so that actually when we rotate it down, this is actually positively above, and then it would all work out. Okay, so let's look at one more example here of doing this. All right, let's suppose that we have something like 0 and okay, let's go up. Let's go like this, and suppose that that is maybe like 4 plus 3i. All right, and then maybe we come like this. So let's suppose it's like 2 minus I or something. Okay. So let's try to find the area of this triangle using the same method. So counterclockwise is like that. So this should be the ground. So we take the conjugate of that. So basically we take this multiplied by the conjugate of this, which is 2 plus I. All right, then we're going to find the OI. The OI, we just look at the coefficients. So 4 times, so it's 4 times 1 plus 3 times 2. So which is 4 plus 6, which is 10. And then that's the imaginary part. And we just divide by 2. And that's the area, 5. We just found the area of this triangle. It's 5. Using complex multiplication. Thanks for watching.